So this is problem 36 from chapter 26. In this problem we are given a circuit that I have already drawn here. And there are some batteries in the circuit. We are told that each has an internal resistance of 1 ohm, and there are some resistances. There is a certain configuration for this circuit. For the first part, they are asking us to find these currents I1, I2, and I3. I did not choose these. These are given in the problem. And for the second part of the problem, we are asked for the terminal voltage of the 6-volt battery. And so this is an application of Kirchhoff's law. And we are going to apply both the junction and the loop rules as an illustration here. We could, of course, just do away with just the junction, just the loop rules, but junction rule is usually easier to handle, and there is at least one junction rule you can always apply in circuits like this. So I'm going to start with that one. Right? So first of all, but before we do that, there's some redundancy in the circuit. So for example, these two, they carry the same current. So these are two resistors in series. I can just eliminate one of them and call the other one a 33 ohm resistor, and likewise I can eliminate these two and call this one a 34 ohm resistor. Right, so this is not going to change anything about the calculation of the currents. It will just simplify my equations in the end. Okay, so I always like to start with the junction rules because they are easy. So if you consider this point, I2 and I3 arrive at this point and I1 leaves, so that I1 must be equal to sum of I2 and I3. Right? Then I have to apply a loop rule. So for that I need to choose a loop. The way I like doing this is I pick up a point and I actually like slightly mark the direction in which I'm going to move through that point. So marking the point allows me to stop when I arrive at point again, and having this visual aid always helps me to figure out which direction I'm going. So let's start here and consider this upper small loop. So over here I eliminated the resistance, there is nothing. I come here, I continue. So over this battery I go over a potential difference of 12. I go from the negative terminal to positive terminal, so that's positive 12. And I move along with the current. So over these two resistors, so this resistor has a value of, I forgot to put it in, 11. Over these two resistors, I move along with the current, so that's the decreasing direction for the potential difference. The sum of these two is 12, so these are like two resistors in series, so that's going to be minus 12 I2, this minus sign because I'm moving along the direction of the current. Then I go over here, I'm now moving over a resistor of 34 ohms along the direction of I1, so minus 34 I1. In fact, there's another one over here, so I might as well make it 35. And then I go over this battery, and I'm going to go from the negative terminal to the positive terminal. That's a positive change, plus 12, and I arrive at my beginning point. This loop should be 0. Okay? This can, of course, be simplified a little bit further. 24 minus 12 I2 minus 35 I1 is equal to 0. Now, as a second loop, let's take the big loop. Again, starting from this point, I'm going to look at the big loop. Going over here, there is nothing. Going over here, there is nothing. Going over here, I'm moving from negative to positive terminal, so that's plus 6. Then I'm moving over a 1 ohm resistor in direction of current I3, so that's minus I3. I will now write explicitly and then do the simplification at the end. Now I move over a 33 ohm resistance in direction of I3, so minus 33 I3. Now I think you could see that I could just add these up. Then I move over here, I'm moving in direction of current I1 over 34, so that's minus 34 I1. Then over this, from negative to positive terminal, plus 12, and now finally over this 1 ohm resistance in direction of I1, so minus I1 is 0, and if we simplify this, this is 18 minus 34 I3 and minus 35 I1 equals 0. Okay, so this is one of my equations. This is one of my equations, and this is my third equation. 3 equations for 3 unknowns. In principle, you can solve this. Now, what will be the simplest way to solve this? This one does not have I3. So I can use this to get an expression for I3 and substitute in here. Then I will have two equations for two unknowns. Okay, so let's do that, and then I will stop there. So from this, I say that I3 is I1 minus I2, and then when I substitute this in here, I get 18 minus 34I1 plus 34I2 minus 35I1 is equal to 0, and I can put the I1 terms together. 18 minus 69I1 plus 34I2 is equal to 0. Now, I need to solve this equation and this equation. Okay? So two equations for two unknowns. You can solve for this. One easy way to do that would be to set the coefficients of I2 or I1 equal to each other, and then subtract them off side by side. Or you could solve for I1 or I2 using one of them and then substitute the other and proceed that way. Okay? But I'm not going to do this. I'm running out of space, and I will most certainly make an algebraic error if I try to fit this into a small area. Now, for the part B, they are asking for the terminal voltage of this of the 6-volt battery. To calculate that, we first have to recall the definition of terminal voltage. Terminal voltage is the voltage that you read from the terminals of the battery, right? So that includes the internal resistance. So this is what you would read if you connected a voltmeter to these 2 points. Okay? Now that will be 6 volts minus I3 times this R, which is just 1. So 6 minus I3. Now, if out of those equations that came out, you find that I3 is negative, then that means this choice of current directions is in fact incorrect for I3. Then that battery is not going to be discharging. So this will be the direction of current if the battery was discharging. If the positive charges were leaving the positive terminal and just creating a current this way, but because there are other stronger batteries in the circuit, these could in fact be charging. So if you find out from those equations that I3 is negative, then this is going to be something larger than 6. If this choice was in fact correct, direction for I3, then this will be discharging. The terminal voltage is going to be less than 6. Okay? But since I did not calculate I3, I cannot really comment on whether this is going to be larger or smaller than 6. Because given this circuit, I cannot readily tell whether this is going to be charging or discharging. It's not trivial to tell, in my opinion. Okay, so that will be all.